Okay, so this screencast serves three purposes. We're going to build an interaction term, we're going to build an x squared term, and then we're going to build some dummy variables to represent the variable that you see, country of origin. This is our grandfather clock data, so it should look familiar to you. The only thing is I added the origin variable. I made that up. So you can see we have 4 countries of origin: Germany, USA, England, and Switzerland. So the first thing that we're going to do is create an interaction term. So remember, with this data set, we're trying to predict the price of the clock with x1 as age and x2 as number of bidders. So what I'll do is I'll go in here first and I'll name a variable interaction. And then in my data view, I'll say transform, compute variable. The interaction term is just a product of age and the number of bidders. So I'll use that asterisk and say OK. And you'll see this column is the product of the first 2 columns. Then the next thing I'm going to do is create an x squared term. So you would do this, you would create a quadratic term if in your scatter plot with y versus x1 or x2 or whatever, you saw that possibly there was some curvature in the data. So build an x squared term into the model by building an x squared term into your data set. Let's fool around with age and let's square age. So again, I'll name the variable first and I'll just say age SQ. And there it is right there. And transform, compute variable. And let's take number of bidders out of there and put age in again. So that's age times age. The other option would just be to use this double asterisk, which is creates an exponential form. Either way, it's fine. So OK there, OK to that, and there's your x squared or your age squared term. So you have interaction squared, and then the last thing we're going to do is build a couple dummy variables to include this qualitative or categorical variable of country of origin into our model. So you can see we have 4 levels of our categorical variable. When you have 4 levels, you need 3 dummy variables. So k levels, you need k minus 1 dummy variables. So we're going to use 3 columns here, and we can just call them x1, x2, and x3. And there they are. Now let's say that USA is the base level. So what we're going to do is everywhere there's a USA clock, every variable, x1, x2, and x3, they all get zeros. So I'll go across or down, and when you're doing this, the copy and pasting tool is going to save you some time. So I'll paste those in there. That's your base level, is USA. And then after that, it really doesn't matter. So we could say let x1 equal Germany and 0 otherwise. So we'll go down here and fill in the 1s, and then I can paste my zeros in there. And I can say let x2 be 1 for England and 0s otherwise. That's England, yep. And then Control V, put those zeros in there. And then the last one, Switzerland, x3 would be 1, and everybody else is 0. And if you don't like the decimals, which I really don't like them either, you can come into your variable view, and then this decimal column, if you click over to the right of the cell, you have a little option to reduce the number of decimals. It'll just look prettier. You could get rid of these decimals as well. You don't have to. 0.00 is going to work as a dummy variable just like 0 will. So there you go. You've got your x squared term, your interaction term, and then 3 dummy variables to take care of, 4 levels of this qualitative variable right here. And then if you were to build your model, you would predict y, price, with x, number of bidders, or x1, age, x2, forget what I'm saying there. And I'm not redoing this thing, so age, number of bidders, interaction, age squared, x1, x2, x3, and you'd put them all in the model. And that's it.